So good afternoon, everyone. Thanks for coming to my non-TED talk. Today, we're going to talk about what happens when you try to run Drupal at scale. And we're going to examine the power of stories. I think that as system builders, we are storytellers by definition. What we do is, as a business, we help our clients tell their value narrative. As architects, we build systems that express our value narrative to our clients. As engineers, we tell stories to a computer that allow the other stories to take place. So this talk was born out of the realization that language maps mind and mind maps systems. Therefore, language maps systems. And the language that we use to tell the story of those systems has a deep impact on what we build. So, who is this guy? I'm Manuel Gomes, and I usually say that I help people and systems work better together in a variety of categories. These days, I work as a project engineer at dropsolid. You may have heard of this company previously today. And yeah, we try to make digital experiences, best of breed digital experiences available to everyone. We're passionate about open source, and we are passionate about being a part of the communities we're in. So yeah, here's me, here's another guy, another one. You may have seen Dominic previously. And he explained this far better than I can, so I'm going to fast forward over this because, yeah. But here you go, you have Drupal, Matic, you know me. We build this, we integrate this, we sell this. And yes, there's the data sovereignty, security, privacy, all built in. These are strong values with us. These values align us with open source, align us with Drupal, align us with the ethos of what we do here. And yeah, this is a tech talk from a weird angle. We're going to talk about stories, about nouns, verbs, adjectives, about semantics and language overall, and about how these tools express this lexicon. So it starts with dropsolid about 11 years ago, or is it 12 now, Tom? Yeah. 11. We founded this, we started growing. Nowadays in production, 700 odd projects, 1,500 environments, 200 servers. That's just production, by the way. And managing it all takes a bit of doing. You don't want to do it manually. You drive yourself mad, or madder, as it might be. So we built a platform. And in a way, this talk is the story of building this platform and what we learned in the process and where we might be going next. It's been a nice journey. I discovered that when all you have is a hammer, everything looks like a nail. It's actually Maslow. I didn't know that. It's like, oh, well, shit, okay. That's cool. So obviously, when we started building a platform for running Drupal at scale, we used Drupal. Surprise, not. And we started thinking about what this platform would do, what it would manipulate, and how it would do so. So we started modeling the business domain. We came up to a few nouns, like project, server, environment, user, organization, etc. And verbs: create, upgrade, archive, clone, delete, etc. And of course, we built nouns the Drupal way, which is custom entities and ACLs for memberships. And we kept state in Drupal as well. That has a story of itself. And for the verbs, we did everything in Ansible, basically. Who here knows Ansible, what it is? Okay. For those that don't, it's a tool for manipulating servers. Call it that. And we'll see some more details further ahead. So we put it all together, and we arrived at this. Don't try to, we'll see each of these components in some detail. But we have our front end, that's built in Drupal, that talks to Drupal itself, REST API, queue jobs, transformation queues, finite state machines, leading to queue processing, leading to Ansible, that in turn does stuff on the servers. What stuff? Well, the verbs apply to the nouns. It made sense and it worked pretty well. And we continued to grow, and we were quite happy with that. But Drupal is not an application framework. It's an awesome CMS. Don't think that this is in any way rubbishing Drupal. Drupal is awesome, but it's not an application framework. Each revision has quite some overhead. Blobs are handled only kind of so-so. So when we had a lot of traffic into the REST API that Drupal so conveniently makes available for us, we started getting deadlocks. And yeah, for our naive start, that was not good. But of course, there's ways around it. We defended with smart queuing. RabbitMQ, a very nice message broker. And Celery, which is a Python queuing library built on top of it. It gave us nice retries with nice backoff. It gave us a reliable interim state store until we could apply those things back into our platform. It gave us at least once delivery. And that is the important bit, because we now have semantics that apply to our nouns and verbs. And Ansible takes care of most of the verbs. You kick off an Ansible playbook that applies roles to the infrastructure, and it returns inventory with the things that we manipulated. Good. So let's talk about Ansible. Sometimes we use it just right. Ansible is awesome at creating, provisioning, configuring servers. It's got a huge ecosystem. It is flexible and extensible. It's perhaps a bit too much of these things, because then we can rewrite configuration files. We can start, stop, restart servers. But Ansible doesn't know its own concurrency. So things can easily step into each other's way. It has no notion of rollback. And, you know, its atomic rights and other atomic operations are literally as good as you make them because they're not native concepts there. Sometimes we use Ansible really, really bad. Poor ducky. Because look, just as Drupal is not an application building platform for high concurrency, look, Ansible is not a programming language, it's not an application framework. You can run arbitrary software through it, but what we noticed is that the separation of concerns was getting progressively harder. So architectures started bleeding over from one concern to the next. Look, it's a lot of orchestration, and it has the problems that we have enumerated already. It's hard to keep track of, so, hey, finite state machines, right? They're CompSci 101. They are you can get deterministic success or failure. You know, if stuff broke, you can resume, you can retry, you can actually roll back if that is part of what you wrote inside the state machine. Nouns, verbs, semantics, grammars. Now we can we can make sentences. These sentences are supposed to have a few characteristics. These are a few of them. They are readable, idempotent. Who here doesn't know what idempotent is? If you say something and you say it again, it doesn't make a difference. Like create. The first create normally would, okay, I've created this thing. The second create would error out, ban. And now you don't know what the hell is going on. Create, okay, create. Yeah, I got it already, that's fine, carry on. And this goes back to that semantic of at least once delivery. At least once means potentially twice, 3 times, n times. If things are idempotent, that's okay, doesn't matter. It takes some design to do it, but you're good. Auditable, you need to be able to see what happened. And ambiguous, atomic, etc. Good characteristics for a business. And maybe this is familiar. As a role, I want to action so that benefit. Or behavior-driven design, like BHAT. Or domain-driven design. That's Eric Evans' a very nice book, Domain-Driven Design. It has a ubiquitous language as a concept, which is a language that all stakeholders agree represents the problem domain. And there are a few funny stories around this, like I once was brought in as a consultant to a company, and they had some problems with their software. One of them was around invoicing. So I asked the obvious question, what is an invoice? I mean, this should be a very common sense sort of thing. Everyone knows what a freaking invoice is. Except that there were 7 different mutually incompatible definitions of invoice within that company. So, again, language is very important. So you have to tend to your abstractions, like they are in Darwin. they require active maintenance and attention, because if we are talking about vocabulary, semantics, grammar, and value narratives, which are unusual things for tech talk, right? There has to be a benefit to it. And the benefit is alignment and decoupling. Alignment means that we're talking about the same thing and working towards the same objective, which arguably is important. And decoupling allows us to expose some functionality, some operation, some system primitive in a way that, hey, if we've outgrown it, we could just swap it out without having to shuffle the entire ecosystem around it. So this is good for the longevity and maintainability and scalability of our systems. And everything breaks at a scale, and I mean everything. What you choose at one point in your scaling journey, it'll break at the next scaling point. That's okay. You should think about the present. You should be mindful of the future, but don't go off trying to build Google for, your 5-person shop. And the higher up you go on the scaling ladder, the leakier your abstractions get. Things start bleeding over, a bit like Ansible and software, that the borders become blurry. This happens even about your concepts. So there's one simple trick. If your nouns, verbs, etc., allow you to form sentences that sound like what your customers are saying, what they are asking of you, then you are probably on the right track. I want to deploy my project to a production environment. Hey, that is absolutely something your customers are going to tell you. I want to build a website. So a good platform will make it easy for you to write these sentences. And if you find yourself writing stuff that is necessary, but that your customer would say, then you're not writing platform. You're writing implementation. You're writing the thing under the hood that you want to be able to swap out at a moment's notice. You're writing infrastructure, you're writing drivers instead of user land. And at some point, someone says, hey, I've heard for a tactile thing. Yeah, okay, sure. So let's talk about Kubernetes. And Ricardo is going to have a workshop afterwards. And let's talk about nouns. Because custom resource definitions. This is sort of the Kubernetes version of custom entities. That same thing, just at a different point of scale. And the Kubernetes API itself allows you to carry out CRUD, create, read, update, delete operations over them. So hey, we have nouns and now we have verbs. Well, we have some of the verbs. Because, our sentences are a little more complex than that. So, never mind the details. This is the decision tree of clone environment when you only have development and production. Of course, there's also testing, staging, QA, data quality and stress, specification, whatever, environments. Well, we've just done this. It's like, well, hey, is A production or development? Is B production or development? In some cases, we truncate data, we anonymize data, we do all sorts of things, yada, 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 yada. And then you actually run the clone operation in your platform. Oh, wow. So maybe we can take a hint from past experience and admit to ourselves that we do need logic, we do need software, and not just, descriptive processing to build this. And, Kubernetes gives us operators. Operators are things that look at your Kubernetes cluster. They see the existing state. They see what you want to achieve. What differences you may want to make. It says, okay, so to go from where we are now to where we want to be, we are going to carry out these actions, and we end up in the desired state. You can write these operators in a variety of things, including Ansible. Poor Dutty is very scared because here comes Ansible again. But that's okay, because at this point, we are not really caring about where we are. We are describing the story, and there is something under it that's going to make it a reality. That means that our platform remains the same and evolves, but it basically tells the value story, and whatever software we are running makes it a reality. So yeah, as long as we are speaking the right language, as long as we have taken care of our nouns, of our verbs, adjectives, semantics, and grammar, we can just evolve by swapping things out under it. And the ducky is happy. This is all about making the ducky happy, by the way. And because not mentioning tools would be yucky on a tech conference, we're going to talk about two things that really required a lot of fiddling in as we scaled up, which was logging and backups. So Rastic for backups is incredible. You aim it at something and say, hey, make a repo here. And it does. You define you are going to back up things from here, except these other things. And you say, hey, back up. It takes it, it compresses it, it stores it wherever you want. NFS, VIO, S3, Google Cloud Storage, data. And that's it. But the next time you create a backup, it will do that incrementally and just store the bits going forward. This means you have point-in-time recovery, which is awesome. And it also allows you to, restore snapshots fully or partially, but you can mount it as a file system. and do stuff inside it, and then go away. This is very powerful. Retention, it looks like cron. And, no worry. If you just done a good day's work, it just works. Now, the Grafana low-key alloy stack is not quite that simple, but it's worth it. You can have alloy is, so the little squiggly thing, it's a log, and actually, it's a thing shipper. Logs are one, but also metrics, and also events. And it ships them to Loki. Loki is a logging database. It gives you not just a record, but an API you can use to manipulate, extract, etc. Then you stick Grafana on top of it, and you get dashboards. So you can even embed your users' Apache logs in your platform control panel and do all the funky OAuth thing and so forth and so on. So this straddles the line between ops concern for your platform team and product that actually has an end user value. Pretty good. And look, that's pretty much it. I hope that I've spoken the right language. I know that this is a bit unusual, so guys, questions are very welcome.
Which Ansible version and how many CRDs?
Yes. Several different Ansible versions depending on where in our stack, what generation of our offering, etc. How many CRDs? What if I know? That's the good part. I sort of stopped caring once our abstractions were right. So yes, we have CRDs. There are quite a few of them. I'm going to estimate a little over 20 and under 40. But anything that you can think to do on an OpenDXP that involves Drupal, Mautic, Udemy, and multiple environments coordinating between them, etc.
There's no concept that you can use for that, no problem.
There are concepts that you can use, but that is only if you are operating in Kubernetes alone. So if you are maintaining a platform that has to have the same outcomes, if they are working on a client VM somewhere that is just your platform has credentials for and can access it and makes it happen, versus your own carefully crafted Kubernetes cluster, versus a customer's random Kubernetes cluster somewhere, etc. If you want to keep the same semantics across it, you have to craft your abstractions accordingly. To use the correct Kubernetes constructs alone would mean that you are forking your abstractions between what you do for a VM, what you do for a shared hosting somewhere, what you do for Kubernetes, and which Kubernetes, by the way. So yes, you are maintaining a different abstraction stack than the optimal for a certain platform. However, you can use those same abstractions to operate on all platforms. So it's a trade-off. Absolutely, you have identified very correctly a decision we have to make. And so far, this is where we are.
One, I'm just saying, being deeply rooted in actual entity-less community, you try to abstract over the native context, building something that has really a high potential to collapse as soon as you get changes in those environments that are natively, and both, get developed at an amazing speed. So with the next next version, you need to rebase all your CDDs, so you will stick to several versions of it that you need to maintain. With Ansible, the same, you stick to several versions that you need to maintain, and then basically you have a cluster hold of complexity that would increase with every release of your upstream communities.
This is exactly why abstraction pending is such a strong concern. You have to keep in mind local accents of your language, right? If you speak Portuguese in Portugal, if you speak Portuguese or Brazilian in Aruba, you're going to get different results. So, because the environment it will run can vary so widely, you want to have very sound primitives that you are reasonably confident, and look, reasonably confident, right? That are going to have an implementation in whatever platform you happen to choose, which means that excessive optimization is not a virtue, unless you have a very strong reason to do it.
Two ways to approach basically the languages. One is to abstract over both of them. On the other hand, is one is to find the least really common words.
Yep.
Which is then network, storage, compute, and then you add some variations to that. And then you can fit it into the native context without having a huge overhead.
Yep. So, which means that you end up having different drivers to your user land, right? And you try to keep this process handled. Because what else is there? Unless you decide to commit fully to something, but that, of course, has its own cost. But thank you, because yes, that is very much a concern. Anything else? Hey. Thank you very much for your attention.